Hello, welcome back to the channel and welcome to a bit of electrical theory. Oof. Not a video I expected to be doing. Now, I've been working on cars for about 13 and a half years, and I'll probably say for 12 and a half of those years I've kind of fumbled my way through electrical sort of diagnosis, if you will. But the past year or so, I think I'm kind of getting to grips with it. So I just want to maybe pass on a bit of information and whatnot to help, other strugglers try and get the hang of it. Now, what I'm talking about in this video is volt drop. So what is volt drop? Well, to me, it is unexpected or unwanted drop in voltage in an electrical circuit. How does it happen? Usually corrosion to a wire, damage from, well, most common cause I see is sort of wiring trapped between gearbox and engine, or chafage can be a cause. I'm gonna draw some circuits on the board, do a bit of explaining, and then I've got a car out there that we're going to put this into practice on. So yeah, let me draw you a circuit and then I'll do a bit of explanationing. Okay, so in our circuit we have a battery with a ground. We have an alternator, and then a positive. Now it doesn't have to be an alternator. You could be a bulb, could be a motor, washer pump, wiper motor, whatever. Does not have to be the alternator. I'm just using this because it's easily accessible on the car that I've got. The only difference with these two is you would have a switch, but obviously with an alternator we don't have that. So what we're going to do, well, first, the battery is obviously full of electrons on the negative side, negatively charged electrons. This wire is obviously conductive, so we'll get some down here as well. And the tool we're going to use will be our multimeter. So the supply, we need to measure voltage two places to start with. The load, consumer, which is the battery in this case, and the supply. So multimeter out, we'll go negative on the alternator to the B plus on the alternator. This is a good circuit to start with, and what we should see is 14 volts ish. Then we measure across the consumer, the load, which is our battery, and we should see something similar. It might be 0.1, 0.2 of a volt difference, so 13.9 volts. Okay, now we're going to measure earth on alternator to earth on the battery. negative side and negative side. Now if you look, what the multimeter is doing is measuring the difference in voltage or electrons at this point and this point. So obviously there's going to be the same number of electrons here as what there is there, because they're free to just, you know, be on that particular piece of wire. So we should see, we might get 0.1 of a volt difference between there and there. And if we measure the same on the positive side, the same will be true. Might be slightly different, who knows, 0.3. But if that were the case, then obviously this would be 0.4 of a volt less than what that is. So 13.6, say. Okay, that's a good circuit. What happens if we have a bit of corrosion build up on our earth wire, which is a common thing to occur? Bit of green. Now these electrons are going to get to about here. Won't be able to go any further. So we'll start again, rub out all our voltages, do our checks again. So supply voltage is going to be the same, to be fair. I don't know why I rubbed that out. 14 volts. Okay, now load at the consumer. Now a normal consumer, motor, bulb, you'd have 0, or you might get 0.5 of a volt here, but because this is battery and it has voltage in it anyway, you're going to be more likely to see maybe 11.5. Obviously remember the vehicle's running, so it's supplying ECUs and stuff if you've got fans on, whatever. So that is what you're going to see somewhere there. If we measure from battery positive to positive, B positive on the alternator, we should still see yeah, close to 0 volts. And now when we come to measure battery negative to alternator negative, this is where we should find, obviously remember on the good circuit we had 14 volts here and 13.6 here, so we've lost, what have we lost here? 2.5 volts minus this, so 2.1 volts. So we should find this when measuring from battery negative to alternator negative. So yeah, 2.2. And then obviously the supply voltage here, 14, all these other voltages should add up to this supply voltage. So 11.5 add 2, 13.5 add 0.5, 14 volts. Now if this was okay and this was, say this was open circuit, you'd have the same situation, just reversed. The 2.2 would be up there, 0.3 down here. These electrons are free to roam. Yeah, there we are. Right, let's see if we can put this theory into practical application. So for anyone that's interested, the car we are testing this theory out on is 2004 Seat Ibiza for two reasons. Number one, the battery was flat, so I thought about time we got it going. And number two, look how easy that alternator is to access. Plenty of room, so we should be able to see exactly what's going on. Right then, so first two checks, I'm just gonna screw a crocodile clip onto here just to make it easier. So the first two checks we said were across the supply and the consumer. Now it's a bit backwards on this because this, now it's running, is the supply. So we'll just earth on here. And then measure off the B plus, which is just on the back. And if we look at that, 14.6. Okay, now consumer. Again, crocodile clip on the negative. I'm gonna, can I move this out of the way? Kind of, not really. Close enough, yeah. And then probe on the positive, 14.56, so we've had 0.05 of a drop, which is nothing. And then the next check was earth on the battery to the earth on this alternator. Exactly what it should be. And then if we move crocodile clip to the positive on the battery, go to the positive on the alternator, the B plus, 0.05. So that's a good working circuit. What I'm going to do now is create a fault. I'm just going to take the B plus off the back of the alternator because it's easy to do. Right then, and we'll see what happens. Now we have our B plus disconnected. We'll go through all the same checks. So negative on the battery. No, not that. Here, negative of alternator. Oh my god. And positive of alternator. So I was fucking crocodile clip. Our supply voltage, 14.4-ish. If we go across the battery, the load, the consumer, we obviously know it's not going to be what it should be, 11.8. So then if we go battery negative to alternator negative, we still get, you know, close to zero, as it should be. Move the crocodile clip from battery negative to battery positive, and then go to the B positive on the alternator. We now get 2.7-ish volts, which is voltage that we're missing. Obviously we have 14.4 volts coming out of the alternator. We had 11.8 at the battery, so 11.8 add 2.7. What does that equal? Close to 14.6. So that is the remaining voltage. So we know there's an issue with the positive wire, which is right, there is. Explains volt drop in a more physical way, more practical way, rather than drawing it on a whiteboard. There we go then, that is this done. Hopefully the mix of practical and theory-based sort of explanation is, you know, has made it easier to digest and understand volt drop. My only other advice would be just to practice it, just to do it. It's easy, obviously, on this. It took 10 minutes. If I wasn't videoing, yeah, we could have done these checks in 5 minutes. Put faults in, see what your results are on your multimeter, and yeah, just practice, practice, practice. The more you do, the more you're going to know what results to expect, what results should look like. Yeah, and that should make understanding it and diagnosing electrical issues a whole lot easier. So thanks for watching. If this video goes well, I might delve into another technical electrical video. Yeah, till then, see you in the next one. Bye.